Good morning to all of you. Today I'm going to give a small introduction in liquids. Especially we call the chapter name as fluids. Okay. So before entering to this chapter, let us have some basics. Okay. So what is this chapter actually? This chapter, for example, a material you will consider the material is of two types. Any material, any substance you consider, it's of two types. One is solids, the other is fluids. In fluids, again there are two types of fluids. Okay, what are the two types of fluids? That is liquids and gases. Fluids are of two types, that is liquids and gases. Solids are rigid in nature. Fluids, the name itself says that they flow. Fluids can flow. And when fluids can flow, what are the fluids then which can flow? Water, liquids can flow. Gases can also be flow. Gases can also flow. So fluids are of two types, that is gases and liquids which can flow. Solids cannot flow because they are having rigid shape. They can slide but they cannot flow. So let me have small introduction to this topic here. So before going to the introduction to this topic, then let us have some small concept here. You all know density is equal to mass by volume. You all know density is equal to mass by volume. Okay. So here, if you observe average density, what do you mean by average density? It is nothing but total mass by total volume. Density means mass by volume. Average density means total mass by total volume. Then average density, if you observe, you can write like this: delta average is equal to total mass by total volume. Okay, so mass, if you consider many liquids of different masses and their volumes are different, you can consider the masses of the liquids as M1, M2 and so on, and volumes can be considered as V1, V2 and so on. Okay, so now let us discuss about a simple concept here. In this case 1, if you observe, if two liquids of equal volumes are mixed, then what happens? Okay, for example, I have taken one liquid, I have taken another liquid. These two liquids I have taken, their volumes are going to be same. Let it be V. They have same volumes. Masses may be different. Their masses are not going to be same. Masses are different. Volumes are same. It's very simple to understand here. Okay. Then volumes are same, I said just now. Okay. Then here you can write, for example, you have taken liquid 1, liquid 2. There are only two liquids. So you can write here two liquids of same volume but different masses. Same two liquids of same volumes but different masses you are considering. Then what is going to happen? Let us see here. So average density is equal to, you will write M1 by M2 and this is going to be V1 by V2. Okay, so here there is no discussion of masses. Is there any discussion of masses? He says that only equal volumes are there. The indirect meaning is masses are different. You have to understand that one. It's a common sense. Okay. No nuisance and nonsense, have some common sense that will come with experience. Okay, let us see what happens. I love quotations, I love rhymes. No nuisance and nonsense because of innocence, have some common sense. It will come with experience. Don't be serious, it is injurious. If it is injurious, the story will become mysterious. Okay, so let us see what is going to happen. They are having same volumes. There is no discussion of masses here. There is no discussion of masses. You have to replace masses in terms of volumes here. So here, what are you going to write? Mass can be written as volume into density. This mass can also be written as volume into density. And these are volumes here, V1 and V2. So I have replaced mass in terms of volumes and densities because he said that there are two liquids having same volumes, that's it. It is understood that masses are not same. That's why we are not taking masses into consideration here. And as it is said that V1 will be equal to V2 equal to V here. So you can write here, both are going to be same. So you write V into rho 1 plus V into rho 2 by V plus V. So if you common out V here, even in the denominator also you common out V, you'll be getting rho 1 plus rho 2 by 2. So VV gets cancelled. So here average density can be taken as rho 1 plus rho 2 by 2, and this formula is applicable for equal volumes. You just remember this concept. So this formula is applicable for equal volumes. Okay, if you have understood this, take a screenshot of the board. We shall go for the next topic. Next, if you observe the second case, that is case 2. So in this case 2, there are two liquids here. These are the two liquids 1 and 2. Their masses are same now. There is no discussion of volumes here. That means it is understood indirectly that the volumes are not going to be same. Then what happens? Let us see here. So their masses are going to be same. Then what happens to the average density in this case when masses are same? I have already explained what happens to the average density when volumes are same. Now we shall discuss about what happens when masses are same here. So when masses are going to be same over here, then you will write formula for average density, that is total mass by total volume for two cases. It is having two cases, so write two masses and two volumes, that's it. So as there is no discussion of volumes here, what are you going to do now? You have to replace volumes. Whatever is not discussed, that should not be present in the formula. There is no discussion of masses, no masses in the formula. Replace masses. There is no discussion of volumes, remove volumes in the formula and replace with masses and densities. So rho average is equal to m1 by m2. This can be written as m1 by v1 plus m2 by v2. Okay, then as masses are same, you can common out here m. You can write 1 plus 1. Here also you can common out mass. You can write 1 by v1 and 1 by v2. Then masses are going to be cancelled here. 2 volumes, LCM. So if you take LCM, you'll write v1 plus v2. So therefore, V average is going to be 2v1 v2 by v1 plus v2. That's it. So this is the formula you're getting when there is equal masses, and this is the formula you're getting when there is equal volumes. So this is called as average. This is also called as average. This is geometric mean. This is harmonic mean. So different averages are different means are different here. So if you understood this concept, you can solve this problem here now. So now You know specific gravity. What is the meaning of specific gravity? Specific gravity or relative density, both are same. Okay, so specific gravity and relative densities are having same meaning here. So let us solve the problem. If you understood, you can take a screenshot of this and try to solve the problem over here. Now it is said that specific gravity. Here, if it is a specific gravity or relative density, what does it mean here? The meaning here is density of a body by density of water. Specific gravity or relative density is nothing but specific gravity is the ratio of density of a body to the density of the water. Okay, so here, as you know that density of water is going to be 1 in CGS system. 1 density of water is 1 gram per centimeter cube for water especially. Then that means that specific gravity and density both are going to be same. Specific gravity and density, you can take density as rho, as we have taken earlier as rho. You can take rho, you can take d, whatever you want you can take. Whatever you feel comfortable you can take here. So now specific gravity will become density because density of water is 1 gram per cc. Okay, specific gravity is a ratio, that's it. Doesn't have any units at all. Got the point? Then go for the next topic here. So how can you solve this problem now? When equal volumes of two metals are mixed together, specific gravity of an alloy is taken as 4. Equal volumes means, equal volumes, what does it mean? Equal volumes means the average density is going to be rho 1 plus rho 2 by 2, which is taken as 4 over here. Understood? Because it said that equal volumes, as we discussed in the first case, equal volumes. Then equal masses is telling. Equal masses are mixed together, then specific gravity is 3 is set. Okay, no problem. Then you can write 2 rho 1 rho 2 by rho 1 plus rho 2 is going to be equal to 3 over here. Got the point now? So here, this is also average, but average in the case of equal masses. This is of equal masses, this is of equal volumes, this is of equal masses. Okay, then what are you going to do? From this you'll understand that rho 1 plus rho 2 is equal to 4 2's 8. Okay, 4 2's 8. Then this is 8. Then let this be 1 and this be 2. Let us substitute 1 in 2. This one you can substitute here. Then what are we going to get? 2 rho 1 rho 2 by rho 1 plus rho 2 is nothing but 8 is equal to 3. 2 1's, 2 4's, or rho 1 rho 2 is equal to 12. You're getting this equation. You're getting this one. Then what are you going to do now? What are you going to do now? He's asking us to find out the specific gravity of two different metals. If you find the densities of the two metals, then it will be equal to specific gravity because you're comparing with water ratio. Water is having 1. That's it. It's very simple. Okay. So what are we going to do now? So this equation, you keep it aside. Now, you know, rho 1 is equal to 12 by rho 2. Okay. So substitute this rho 1 equal to 12 by rho 2 in equation number 1. Here we're going to substitute. Then what are we going to get? Let us see. You'll get a quadratic equation. Yes. Then you just see here. So instead of rho 1, you're writing now. So let us write one equation once again. So rho 1 plus rho 2 is equal to 8. Instead of rho 1, you'll write 12 by rho 2 plus rho 2 is equal to 8. Then LCM, if you consider 12 plus rho 2 square by rho 2 is equal to 8. This implies that 12 plus rho 2 square is equal to 8 rho 2. Then rho 2 square minus 8 rho 2 plus 12 is equal to 0. Okay, so then it is a quadratic equation. It is a quadratic equation. You can write it as rho 2 square minus 6 rho 2 minus 2 rho 2. 2 rho 2 plus 12 is equal to 0. Then what happens? Let us see. 6 2s are 12. So minus into minus plus. And this is minus minus. If you add, you get 8. So we are going to resolve into 2 components here. Let us have some space. Then you're going to do this one the very simple way. Rho 2 if you common out, you'll be getting rho 2 minus 6. Minus 2 if you common out, you'll be getting rho 2 minus 6 is equal to 0. So rho 2 minus 2, rho 2 minus 6 is equal to 0. What do you find now? So getting two values for rho 2. What is that? The meaning here is if rho 2 is equal to 2, then rho 1 will be 6. And if you consider rho 2 as 6, then rho 1 will be 2. Okay, so these are the values of rho 1s and rho 2s. That is nothing but specific gravity. That's nothing but specific gravity. It's a very simple concept. Okay, so